Another thing that caught my attention when you were explaining is viruses and chronic diseases like diabetes and heart disease,
Yes.
which are traditionally not identified with viruses. So what is the relationship there?
Right, yes. So that's a really cool question. And what happens, and you're seeing that with this virus also with the children with in the inflammatory, the multi-system inflammatory disease that these kids are showing, that the virus infection happened weeks ago or months ago, and now you're seeing this multi-system organ failure. It's the same thing with type 1 diabetes. You have to have, it's complicated in the sense that you have to have the genetic susceptibility for the disease. You have to have environmental triggers. So with type 1 diabetes, what we know, it's not always the case, but in some cases, Coxsackie virus infections will happen months before type 1 diabetes develops. And that's in an individual or individuals with the genetic predisposition. They have these genes that make them, most people, they'll get, these kinds of viruses and they'll be fine. But the people with the genetic background that says they can't recover in a normal fashion, they mount, and it comes back to the same thing we're seeing with this virus. They mount an aberrant immune response, and that immune response destroys the beta cells in the pancreas for type 1 diabetes, for example. And in the heart, it's the same thing. The virus disappears, but the immune system is still going. It hasn't been shut down. There's a dysregulation of immune responses, and it's the immune system that ultimately destroys the myocytes in myocarditis.
Okay, it's something similar to cervical cancer. Cancer is not triggered by viruses, but cervical cancer, there is evidence that a virus affects, like you're saying, right?
Yes, and so this is the thing. I mean, like cervical cancer, yes, you've got all the papillomaviruses and serotype 16 in particular. So that's the thing that to me is really intriguing. And it's very difficult to study because when you study this, you set up animal models. So we were working with mouse models. And then, of course, a mouse is different from a person. So the answers that you get studying mice may not necessarily translate to what's happening in people. But you do get some clues. And the ability, so the immune system to me is fascinating. It's really fascinating. If you have a controlled response to an infection, you're good. Everything is good. Virus is controlled, the immune system shuts itself down, everything is good. But if there's some glitchiness in the control of that response, if it doesn't shut down or if it heads off into a slightly different direction, then things can get really bad. And so it ends up being a disease of the immune system and not of the virus. The virus triggered it and left, and then the immune system went awry.
Okay, so now that you touch upon the immune system, one thing that puzzles me, because I'm not a scientist, uh, the cause of disease in corona and COVID-19 is precisely the immune system, right? The response of the immune system is what causes the pneumonia, etc. Am I right?
Okay, so again, this is very complicated. So if you think about the immune system, when somebody's doing work upstairs, construction, so there's some noise.
We have the same problem.
Yeah,
In my building too.
There's some noise in the background. Okay, so when a virus comes in, okay, the first part of the immune system is called the innate immune system. And that part of the immune system is a non-specific response. And that's the part that says, okay, I sense something and we're going to start making some inflammatory molecules and we're going to try and contain the infection. And then we're going to signal for the second part of the immune system, which is the specific part, where the immune response recognizes specific pieces on that virus. And so the first part of the response, non-specific, trying to contain. Second part is very specific. And then the third part is where the specific cells that come into play to keep that virus down, some of those cells become memory cells, so that later on, when you see that virus again, those memory cells that will say, hey, we've seen you before, they become activated and they clear it before it can cause disease. So with corona, what's happening is that very early response, corona is dysregulating that response. It's causing the response to go high. It's causing it to stay high. And by doing that, it is also, it does this. Okay, so viruses have some crazy tricks, and this is one. Corona is suppressing part of that early response that is involved in activating the specific part of the immune response. So by suppressing that, it's delaying the development of these cells, and that allows the virus to replicate quickly and spread all over. And then what happens is the inflammatory response that started early in some people, that is just going on and on and on. So you're seeing these inflammatory cytokines, you're seeing IL-6 and TNF-alpha, IL-1 that stays high. And those immune molecules cause a lot of damage in tissues. So it's a sense that the immune system just haywire. Regulatory things that you control no longer play. So the immune system is out of control. The virus is replicating and doing its thing, and then the virus is gone, and the immune system is still kind of trying to catch up because it's had, there's no control. So it's very complicated.